Alright, so what we're going to try and do now is we're going to try and connect the quantum theory with the periodic table. The first thing you want to look at is the different blocks that exist on the table. We can take a look at this picture here. The first two columns are the S block, as you can see. The columns from boron over to neon are called the P block. The transition metals, the 10 columns you see in the center, that's the D block, and then sometimes these are called the rare earth elements. Inner transition metals, there's lots of names for these, but these are the F block. And what you notice is that the maximum number of electrons that each sublevel holds is the number of columns. So in other words, an S block holds 2, and there's 2 columns. An S sublevel holds 2, and there's 2 columns. A P sublevel holds 6, and there's 6 columns. A D holds 10, and it's 10 columns. And an F holds 14, and it is 14 columns, although these are sectioned off a little bit from the rest of the table. Helium's kind of an exception. It actually can go here and be part of the S block, but because it's a noble gas, they place it over here with the other noble gases. So let's say that we were trying to predict the ending of an electron configuration. Well, it's very easy. You have over here, you have your different periods, period 1, 2, 3, 4, 5, 6, and 7. So let's try lithium. If we were writing the configuration, it would be 7 and 3. So we'd have to count for 3 electrons. So we follow our Aufbau principle, 1s2, 2s1. And we see that it ends in 2s1. Well, the ending is attributed to its location on the table. The 2 is the row. We see it's in the second row. And the S1, well, the S is the block. And the 1 is the first column of the S block. And of course, this doesn't help us with the inside of the electron configuration, but it does help us predict the ending, which is sometimes pretty important. So, depending on what you're looking at, let's look at silicon. So let's see, we would write 1s2, 2s2, 2p6, 3s2, 3p2. Now what row is silicon in? It's in the third row. We see it ends in 3. And what block is it in? It's in the P block, so there's a P. And what column of the P block? It's in the second column, so that's why it ends in a 2. So you can look at any of these elements in the S and the P block and predict their ending of the configuration. So let's look at bromine. Well, bromine's in the 4th row. It's in the P block, and it is in the 5th column of the P block, so it ends in 4p5. Xenon is in the 5th row. It is in the P block and is in the 6th column, so it ends in 5p6. So it's a very convenient way of identifying the ending of a configuration, and it'll help you predict what's called valence sooner. We'll talk about that. Now the D block's a little harder because typically the row is 1 more than the coefficient. So for example, chromium, let's say. You might think chromium's 4d4, but it's not. It's actually 3d4. Remember, we don't do this numerically, we're doing this by energy level. So even though it is in the 4th row of the periodic table, it's actually in the 3D sublevel. So anything in the fourth row that's a D block element along here is going to end in 3. So if it's in the fifth row, it's going to end in 4. If it's in the sixth row, it's going to end in 5. And if it's in the seventh row, it's going to end in 6. So palladium, for example, is a D8. So we already know it's a D8. But what is the coefficient? Well, it's in the fifth row, so it's going to be 48. Osmium is in the sixth row, but that means it's going to be a 5D. And what column of the D? The 6. So 5D6. How about hafnium? Hafnium is in the sixth row, so it's going to be a 5. D, what? Well, it's in the second column, so 5D2. So it's a very convenient way to identify where something is. Now, you can also predict the F block, but the F block is a little complicated. We're not really going to get into it in the first year chemistry class. But it is actually 2 off of the coefficient. So something in the sixth row would be a 4F, and something in the seventh row would be a 5F. All right. So just for review, our group 1 elements are always going to be S1s. Group 2s are always S2s, and then starting with the group 13, the boron family, going down that column, those are all P1s, P2, and so on. The one thing you have to remember is helium is not a P6 element. It is an S2 element. So this is not a P6 element. It's an S2. All right, so hopefully that is going to help you a little bit in predicting your electron configurations. And we'll continue with part 8 later on.